Hello, so we are back, and this time we have a nice laptop to repair. Like usual, Acer Nitro, i7 9 Gen and RTS graphics. Now, if you check this laptop, clearly you can see the customer messed up every screw possible. So this one has a bump there on the plastic. Here, another one, here, another one, here, another one, here, another one, and here, another one. Yeah, so that's what happens when you use longer screws. Now, this job is coming from a computer shop. I really doubt they do something like that. The computer shops knows. And I know when I'm screwing the screw on the laptop, if I feel actually it's not getting stuck like instantly, I know it's going into the plastic. So yeah, you can feel it. You can feel it when it's going and it's pushing the plastic. No, the computer shop cannot do something like that. This is clearly the customer mess up with the screws. Anyway, this is a 17-inch screen, 120 hertz. A nice one. The problem with this one, it was supposed to come on, but it's not coming on. Let's check the computer shop letter. So, what they are saying your favorite Acer Nitro 5 works on mains power, fails to charge the battery. Original battery was replaced by customer. What happened in my focus? It was replaced by customer, and those accept charge from the bench power supply and charges. That means the battery is good. Charge to 14.5 to see if the laptop will begin charging. It did not. Battery is detected in Windows and shows 0% plugged in. That means the battery is speaking with the EC chip. I'm guessing it may be Intersil chip 8A739A. Do you have this chip? Can I send one to you? Now, I'm not sure. Maybe this is a new model. But Acer Nitro, they have a BQ chip, power management chip. They don't have an Intersil chip. Maybe this one is different? Huh? I will say, let's open and check. Now, if you are here from a long time, what is the reason why a laptop it will not charge the battery? A gaming laptop, let's say gaming laptop. Yeah, gaming, especially gaming laptops. And we had a few. They worked, but they didn't charge the battery. You remember? Leave me a comment. Let me see you know. Leave me a comment. And actually, the issue is the first MOSFET. So the laptop is working fine on the charger, but the big chip has a MOSFET short circuit detection. And you will have two problems. One, it will not charge. Second, it will shut down on heavy gaming. So yeah, it can be the first MOSFET. Yeah. So how you can know if it's the first MOSFET? Very simple. When you connect the power supply, the laptop is off. It will take insane amount of current. If you see it's taking an insane amount of current, you know the first MOSFET is shorted. Yeah. Let me plug a charger. Yeah, we do have a blue Acer. Let me raise the current. Yeah, like 4.5 amp, 4.6. Good. So if we are plugging the charger, yeah, here. Wait, this Acer has the charger here, so definitely it's a different model. No, and we have the charging light. No, this is not the first MOSFET shorted. No. You know what? I can swear I never seen Nitro with the charging port here on one side. This is the first one. I will say let's open and have a look inside. Did you see Nitro with the charging port on here? Usually they have the charging port here. So I think they can be right. So it's possible here we don't have a BQ chip, we have a different kind of chip. Possible. But hard to believe. I mean, these kind of chips, like, you know, the one they buck and bust. Usually they are, yeah, but can be. I don't know. Let me open the laptop. The gaming laptops, they have the main power rail from the charger. Yeah, it's like there is no chip and no power supply, which is recreating the main power rail. That's why I'm surprised about this laptop. But let's see. Because it's a lot of current. It's kind of pointless from 19 volts to have like a power supply, buck and bust with 4 MOSFETs. It's pointless because this charging port is normal. Usually buck and bust power supplies are used where you have USB-C. So that power supply can take power from the battery and buck or boost even on the output. You know what I mean? So this is strange. But let's see. It's taking no current, nothing. Before we are opening, let's press the power button. I'm pressing the power button and the laptop, it is coming on. Check there. Yeah, it's working. Yeah, over 3 amps. Oh, lol. It's the battery is holding the charge. Now the laptop is off and it's not charging. It's not taking any power. Good. Let's take the back cover out. Okay, this is a new job. It's a new challenge. And I love challenges. Let's see what fault can have this laptop. I'm more interested how this fault can occur. No? Yeah, definitely this is a new board. Yeah, never seen this board before. No. No, I didn't see this board before. And here you have a keyboard adapter. Yeah. I mean, it's quite interesting. So 1 second, the battery is here. Yeah, that chip can be our power management chip. Let's have a look under the microscope. You know what? They are right. They are right. So this chip, it is. I check here has a lot of dots on it. Yeah, someone check here around the things. This chip, it is charging the battery. On this case, let me understand the schematic. I'll plug the charger, so the charger is plugged in. The voltage on this chip is 19.6, and it's right. Still, something doesn't make sense. I mean, this is the comeback MOSFET, yeah? From the battery, yeah. If this is the comeback MOSFET, who is driving this coil? I mean, yeah, the chip can drive MOSFETs, but not the coil. So where are the MOSFETs which are driving this coil? That's my question. Are not here. Possible on the other side of the board? Possible. So this is the current sensor. Yeah, probably this is the current sensor. Yeah. So clearly this is the coil. This is the output. The current sensor is here. But the coil is driven by some MOSFETs, and the MOSFETs probably are on the other side of the board. That's what I think is the configuration here. Still doesn't make sense. So here is the input, and we have no MOSFETs. So I'm assuming the MOSFETs are on the other side of the board. Because I would love to check the first two MOSFETs. But no, the first two MOSFETs are also driven by this chip. 8A739A. Let me find it online. So check here, yeah? This is a basic schematic of this chip. And you can see, yeah. So check here. The first two MOSFETs are driven by the chip. Then we have the charging power supply, yeah. Then we have the comeback MOSFET, which is here. So on the board we can see only this MOSFET. We can see the coil, but not those these two MOSFETs and the input MOSFETs. But I want to check them. I don't want to check the charging ones. I want to check the input MOSFETs. Yeah, that's what we have. Maybe I can find a proper data sheet. Yeah, this is a proper one. No, same. I can't find a proper one. Basically, if you have this chip and you are looking for data sheet, don't look. You cannot find it. I know. Kind of stupid, but what we can do. Okay, let me take the motherboard out because we don't have any other option. Just give me like few minutes. Okay, so the board is out. And yeah, so check here, yeah? Here we have the charging MOSFETs. And here we have the both input MOSFETs. Let's have a look under the microscope. Let's see. You know what? I believe we had before this kind of board for repair, this kind of Acer Nitro, because I remember the MOSFET position. So yeah, we had this model before for repair. But one second, what is this? This is liquid damage? This is liquid damage, right? I mean, check here. I mean, this track is gone. Check it, and this track is going to the current sensor. This is the look here. This is liquid damage. No, this is no liquid damage, but definitely here it was. So check here, check here. So this is some sweet liquid here. You can see it, sweet liquid. Yeah, this is liquid damage. One second. Oh, no, this is the with the GPU. But it's only here. Yeah, that's all. Only there is liquid damage. Here is some kind of dust. No, only there. Only there. Let me check on the back of the keyboard. Yeah. Okay, we can see now. So check that, yeah? Check that. So the liquid damage was exactly here. Exactly here. This area. You can see it? Yeah, there. Otherwise, it's looking fine. You see the plastic. But not here. Not here. Here it was liquid damage. So we clear about the fault? Yeah. Now, how we are cleaning? This is a sweet liquid. I will grab some water. Yeah. I mean, even here. No. Yeah, even here. Here is some sweet liquid. Yeah, we have some fizzy water here. Let's drop a tear. Yeah, that's all. And my toothbrush. and now it's clean. Yeah, perfect. Perfect. I mean, that track is gone from the from the current sensor. This one, I believe this track is gone. It's going to these resistors. Okay, let's check the continuity between the resistors. Yeah. So from here to here, we should have like 0 ohms. We have nothing. Check it, nothing. We should have 0 ohms because the tracks are going exactly here on the parallel with this one. And here we do have 0 ohms. So which one is broken? Let me find out. So from here to the resistor, this one is gone. This one is gone. Lol, both are gone. So both tracks are gone. Now the solution is very simple. We can short I mean, if you have this job, you just apply here some solder, and you charge money for the repair, and you charge money for the power mode. Yeah, because if you short here, then the laptop, it will not see the input current. That means you can do some tricks with the GPU. If you also short the GPU current sensor, but not sure if this board has a current sensor for the GPU, but you can do some tricks. But yeah, no, we are not doing. We are just repairing the tracks. This. I mean, this was a crazy fault, right? And the customer want me to replace the chip. You know what? I don't even have the chip. I was hoping to be something else. It feels bad. I mean, I didn't told them, send me the chip, because it feels bad. I mean, they have the chip, I don't have the chip. And I didn't said anything about the chip. And the worst case scenario, I can buy the chip. That will be fine. But yeah, we don't have the chip. We don't have that ISL chip. So you understand the fault. Obviously, if the power management chip cannot see the current, it will not charge. I mean, that power management chip has to have some data in order to work fine. And we have this track. Yeah, from there, here. Perfect. Check there. Huh? What do you think? Cleaning? No, Rosin is a very good isolator. No, you don't have to clean it. No. Checking the first MOSFET, we can do that, yeah. So checking the first MOSFET is good. The second MOSFET is good. Not sure about the... Yeah, let's check this capacitor. No, it's good. And this one is good. Perfect. Now let me dry the board. We still have some water there. We don't want to create water damage. So you understand? Yeah? If anyone asks you, like, the customer asks you, wait, bro, but you didn't clean the board. It's like, no, I didn't charge you extra. I apply, a protective layer over the solder. And I had to charge you extra, but I didn't charge you extra. So yeah. Yeah, I went the extra mile for you. Now let's test it. A quick test. quick test, meaning we are plugging the battery. Let me be sure we are not doing something stupid here. So plug in the battery and plug in the charger, and the battery should charge. The charger is plugged in. It's not charging. Lol, check that, 2 amps. Huh? It is the charging current. What do you mean the board is on? No, it's the charging current. 2 amps. Because if I unplug the battery, the current goes to 0. So it is the charging current. Just give me a few minutes to put the board back, yeah? Few minutes. Yeah, let me clean there first and I will put the board. Okay, so it's all back in place. Plug in the charger. Let's see. Yeah, check that, like 2 amps. And the voltage on the battery is rising, most likely. The battery we have 15.3 and it's going up, you can see. Yeah, so it's charging fine. Not even point testing on Windows. Because the battery is charging, the fault was pretty obvious. Pressing the power button and probably my power supply it will switch off because I don't have enough current. Yeah, it's off, you can see. The laptop is still working, low battery. Yeah. And it's coming on. Yeah, okay, it's going to for the repair. Yeah, I can see the power supply LED, the current LED is flickering. That's the reason why it's check that it's 0 current. And now it's running on the battery. So in order to activate the charger again, I have to plug the charger back one more time. And now it is charging and it's taking current. Yeah, but it's still flashing. I don't have enough current. Anyway, the laptop is working fine. Yeah, let's see the Windows loaded just to, just to be sure everything is fine. Just have in mind when you have this problem, don't jump straight on the IC. I mean, yeah, on this case, we don't have a data sheet to check, some voltages on the chip. And the Windows it's on. Yeah, it is on. It's not charging because the power supply is disconnected. It's taking no current. So if I plug the power supply, now it is charging. See the charging sign, and yeah, it's flashing again. It's turning. Yeah. You know the story. Okay, fantastic. I'm happy I helped the customer. Just just a drop of liquid damage. You seen that? And more than that, that liquid damage actually corroded. I think that happened. Or was some mechanical damage what broke the tracks? No, probably from liquid damage. The liquid corroded the tracks. Yeah, so pay attention and check the board properly. Yeah. Sometimes you can have liquid damage in places you don't even imagine. Good. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.